Welcome everyone. In this lecture, we will solve some problem based on a scalar electric potential and vector magnetic potential. Look at the problem here. So in this slide, actually I show the step-by-step approach for solving this problem. So you need to sketch this configuration and then find the vector magnetic potential from the expression will be given, and from this vector magnetic potential, you have to find the time domain or frequency domain expression. Then you have to find the magnetic field expression. So we are given a configuration having the equation rho equal to a, phi is between 0 to 2 pi, and z equal to 0. And this configuration carrying a current I equal to I naught, the magnitude. Sine phi also the magnitude, that is the function of phi, and cosine omega t in the direction of a phi. So let me draw the configuration first. So this is my configuration here. Uh, Circular this configuration, but this is the y-axis. Here we have the x and the z. So this has a radius rho, and phi is from 0 to 2 pi, equal to 2 pi, and z is equal to 0. Now we have to find the current is located in this direction, Fi direction. That is current, it is time varying current, IT. Now we have to find the vector potential A at this point. So this point got an coordinate values 0, 0, z. So we need to find the potential A, and the expression for A is mu, the retarded current I, dl for pi, magnitude of R vector minus R minus vector this. So for this equation, we have to find dl, R, R prime, and the retarded current. So let me find R first. So R is the distance from position vector from origin to this observation point. So this is the point of observation. So the position vector from origin to this point is R, and the position vector from here, from this from origin to any point on this line. So let us think this is my differential element. So dl prime. So the position vector from origin to this dl prime is r prime, and this dl prime is basically rho d phi prime, and here rho is 1 a, so you can write a d phi prime. So now we have to find r prime, and we already showed dl prime here. So let us find r. So r, the position vector from origin to the observation point. So here you see the observation point got 0, 0, and z. At origin has 0, 0, 0. So you can write z as z. And the position vector for any arbitrary point on the source is r prime equal to a rho prime. Now r minus r prime is equal to z az minus a rho Now if I find the magnitude r minus r prime, magnitude will be square root of z square plus a square. At dl prime we already obtained before, that is a d phi prime a phi prime. Now if I want to find the current, so I prime will be I naught sine phi cosine omega t minus omega t prime. Now t prime is the delay time. So t prime is the delay time. T prime will be, delay means the time required to travel the signal, right? So time required to travel the signal from this point to this point from the source, from the source, from the source point. So this is the time required to travel a signal from here, from this point to that point. So this will be r minus r prime. So this distance will be r minus r prime magnitude over the speed of propagating the signal from here to that point. So we can write it like magnitude of r minus r prime over the speed. So now we substitute this on the equation. You'll get I naught sine phi cosine omega t minus omega r minus r prime magnitude over, so u here. So this, in this case we have free space, so we can write I naught sine phi cosine omega t, and write I naught sine phi cosine omega t minus omega, and this value is z square plus a square over c, over c. Now let us find the vector a, that is equal to the line integration of mu psi with mu, then retarded current I. So we can put mu naught because it is free space, dl prime over 4 pi r minus r prime. Yes. So now substitute these numbers. So a is equal to, so the, we should integrate this. So we have mu naught, the current is I naught sine phi cosine omega t minus omega the square root of z square plus a square over c a d phi prime a phi prime 4 pi z square plus a square. If you want to put a phi prime, you can do that. If you want to skip a phi prime, you can also skip this. But if you put a phi prime, don't forget to put prime here too, sin prime. So this prime basically optional. If you want to put it, it is really something referred to the source. So current is on the source, so you can write sin prime. sine phi prime and cosine phi prime. Now let's set the limit. So phi is we have to integrate this with respect to d phi, and d phi is varying from 0 to 2 pi. So I put 0 to 2 pi here. So let us take all the constant terms outside the integration operator. So if I take back all of them, so you have mu naught I naught a. So mu naught I naught a, and this cosine also constant term, and 4 pi z square a square. This is also a constant term. So you write 4 pi z square plus a square, and also cosine omega t minus omega z square plus a square over c, and the term that is function of phi is 0 to 2 pi limit sine phi prime a phi prime d phi prime. So now we need to integrate sine phi a phi with respect to d phi. A phi is also a variable and sine phi is a variable. Both are varying with respect to phi. So we have to substitute a phi or convert a phi to Cartesian coordinate system. So to convert this, I write a phi with respect to ax and ay. So a phi basically is equal to minus sine phi ax plus cosine phi ay. I put them in my equation. So if I put the things in my equation, then I will get a vector equal to mu naught I naught a over 4 pi z square plus a square cosine omega t minus omega z square plus a square over c, and these things will be 0 to 2 pi sine phi prime minus sine phi prime ax plus cosine phi prime ay and d phi prime. Now we need to integrate this. So if I write sine phi, and so we have sine phi prime minus sine phi prime ax plus cosine phi prime ay d phi. So that is basically 0 to 2 pi sine square phi d phi prime ax plus 0 to 2 pi sine phi prime cosine phi prime d phi prime ay. Now this will be negative 1 over 2, 0 to 2 pi. So sine square is 1 minus cosine 2 theta. So 1 minus cosine 2 phi prime d phi prime x. And sin theta times cosine theta is half 0 to 2 pi sine 2 phi prime d phi prime ay. Now integrating and substitute the values. So this is 1 over 2. The integration of 1 will be 5 minus cosine, integration of cosine will be sine 2 pi over 2, and the limit is 2 pi 0 in the direction of x, plus half, integration of sine will be negative cosine 2 pi over 2, 2 pi 0 y. Now if I substitute the limits, we'll get half 2 pi ax, and this will be 0, this term will be 0, this term will be 0. Now I will get ax equal to minus pi ax. So we substitute this to the potential expression. The equation will be now equal to mu naught I naught a over 4 pi square root of z square plus a square cosine omega t minus omega square root of z square plus a square over c, and the integration is uh, give us is we get the value for integration is pi ax. So therefore, we'll get a equal to negative mu naught I naught a over 4. I cancel out this pi with this pi. So it will be z square plus a square root cosine omega t minus omega z square plus a square over c ax. So we have to find as in frequency domain. So to find as, basically we need to remove this omega t term. We have to remove this omega t term from the expression. So and this is the pi phase angle. So this is the phase angle. So this is the phase angle, and here this is the magnitude. So this is the magnitude. So in frequency domain, we need the magnitude and the phase angle. So I write AS is equal to negative mu naught I naught A over 4 z square plus a square, and so the phase angle will be this one. So you have to write phase angle. So I write in exponential form. So it will be E naught j omega z square plus a square over c, and the direction is ax. So this is the frequency domain expression for AS. Now to find electric field, we have to apply the formula negative delta V minus partial A over partial T. So here it is said that the scalar potential, this is 0. The scalar potential, this terms is 0. The question says, so you have to write only only the negative partial a over partial t. So you take the time derivative of this, you find e. So you can see the slides to find the result, and finally you are asked to find to express a's, or is it possible to find a's from this expression, from the a expression? You know, the a's is equal to b of mu, and b is equal to, so I write mu naught is equal to mu curl of a over mu naught. Curl of a is a very generalized function. This is a derivative. So curl is a space derivative. So we are required to general expression. So that requires a general expression. But this is not a general expression. The a that we derived before, found here, is not a general expression. So there is no x and y in this. So no x and y, only z. So this function has no x and no y term, only z term. So we can find a's only in z direction. So we can find, so we can only find z component of a's from the obtained equation.